Hello, my name is Grace Bob, and I'm so glad you could join me for my science fair presentation today. Herbicide resistance has been a problem for many farmers and gardeners alike, resulting in increased cost on herbicides. The sweet potato can provide chemicals such as bisetocerol, palmitic acid, and methyl ester through the roots and leaves. Evidence of these organic herbicides has been proven through an extensive amount of studies, such as the sweet potato's effects on the root of the yellow nutsedge. The objectives of this experiment was to determine the sweet potato solution's efficacy on the pre-emergent growth of ryegrass, radish plants, and yellow nutsedge. For each study, extracts from the solute came from pulverized sweet potato leaves, in which they were placed in an Erlenmeyer flask with 100 milliliters of water and 1 gram of the grinded leaves and put into a shaker for 24 hours. In study 1, we screened 15 cultivars on 6 different types of weeds. After a 2-week period, seed germination and plant length was calculated. Study 2 also consisted of 15 cultivar extracts on ryegrass and radish seeds and were measured by their mean time germination and their germination percentage. In study 3, 4 efficacious cultivars were selected to control yellow nutsedge germination. In the final study, study 4, 3 cultivars were used on yellow nutsedge seeds through 4 replications where its MTG and germination percentage were accounted for. The different colors represent the individual cultivars tested throughout the experiment, and the letters above signify the similarity between each cultivar. For example, cultivar blue has similarities with bonita, while it would have no similarities with 13-81. In Figure 1, the inhibition of radish seed germination reveals statistically significant results. In Figure 2, seed germination of ryegrass can be seen as not statistically significant. In Figure 3 and Figure 4, there were no significant differences for MTG of radish and ryegrass. In Figure 5, the total seed germination of 2 replications was calculated and resulted in statistical significance for 3 cultivars. Similar to the results concluded in a previous experiment done in Japan, Study 2 revealed that Bellove 11-119 and bonita resulted in 50% or above in germination inhibition. Though the studies performed in Japan resulted in higher germination percentages, this can easily be explained by the differences in soils they used, as well as the different cultivars, which may have contained higher allelopathic chemicals, hence to higher germination inhibition. In Study 4, the yellow nutsedge seed germination was decreased significantly, though on the contrary, findings have suggested that the yellow nutsedge weeds are very invasive in sweet potato farms, but other findings conclude, such as the experiment that I performed, that sweet potatoes can have significant germination inhibition of the yellow nutsedge. So how can all this information be applied to our world today? Using a sweet potato cultivar solution would not only eliminate herbicide-resistant weeds, but it could also provide farmers with a cheaper and effective form of organic herbicide. The use of allelopathic chemicals can also decrease environmental damage, lessening chemical exposure to humans, flora, fauna, and water systems. Ultimately, sweet potato cultivars Bellove 11-119 and bonita have been determined efficient in suppressing seed germination percentage of the yellow nutsedge, radish, and ryegrass seed. And here are my references. Thank you so much for watching.